Once you've started the software, click on the new project, give the appropriate name, set the proper units, and press OK. The next step is usually to set the material properties. But since we know that there is no need for any other material rather than PEC for the Yagi Uda antenna, so we skip this step. The next step is to design a driven element of cylinder for modeling of wire-type Yagi Uda antenna. This can be easily achieved by creating a cylinder made up of PEC material. Since Yagi Uda antenna is a straight collinear wire with a small space between them, hence we need to design the other part of the antenna also. Again, repeat the same process and press OK. The next step is to design a reflector of cylinder for the modeling of wire-type Yagi Uda antenna. This can be easily achieved by creating a cylinder made up of PEC material and entering the proper transversal coordinates. After creating a reflector, we need to design a director of cylinder for modeling of wire-type Yagi Uda antenna. For this, we again need to create a cylinder made up of PEC material and entering the transversal coordinates. Once we've done this, we need to create two more directors, and hence we need to repeat this process 2 more times. Enter the transversal coordinates x1, y1, z1, radius and height. Again, values of x1, y1, z1, radius and height. The next step is to add the ports to the Yagi Uda antenna, for which the S parameters will be calculated later. Only one port will simulate the Yagi Uda antenna structure, that is connected in the small space between two PEC wires. To define the port, go to the excitation, choose the voltage port, give the proper name, enter the appropriate dimensions to define the exact port, and press OK. Now we need to provide the values for the surrounding space. So enter the proper values of Xmin, Xmax, Ymin, Ymax, Zmin and Zmax. Now we need to set the boundary conditions, and after doing so, the next step is solver settings. Open the solver, provide the various settings as per the formula and press OK. Now we need to provide the value for the far field probe. Once that is done, we need to save the project by giving it an appropriate name. Once the project has been saved, we need to press the simulation button to start the calculation. On pressing the button, a progress bar will appear in the status bar, displaying some information about the solver stages. Once it has been completed, we can review the results.